A class of material which belongs somewhat between these two classes of materials is the semiconductor, which has got a finite non-zero band gap between the valence band and the conduction band. So, at absolute 0 all the electrons remain in the valence band, and as you provide some energy above the absolute 0, as you increase the temperature, the electrons they get some kinetic energy, and if they have a sufficient amount of kinetic energy as to overcome this band gap, they get promoted to the conduction band and they are designated as free electrons. So, at normal temperatures you will at room temperatures you will find few electrons, which is much less than that of a conductor. You will find a few electrons, free electrons in the semiconductor. Now, the conductivity of these semiconductors can be reasonably increased if you dope it with some impurities. So, if the semiconductor is devoid of any impurities, it is called an intrinsic semiconductor. So, if you consider the structure of a silicon atom, then a silicon atom normally is sp3 hybridized, forming a tetrahedral structure in space. So, each silicon atom is bonded to 4 neighboring silicon atoms by this bond pair electrons, forming a covalent bond between 4 silicon atoms surrounding the silicon atom. So, each of these silicon atoms are sp3 hybridized, which means that the 2s and 2p orbitals of silicon they hybridize together to form 4 equivalent sp3 hybridized orbitals of silicon oriented tetrahedrally in space with a bond angle of 109 degree 28 minutes, forming the SI bond angle. Now, under normal conditions at absolute 0, all these electrons are located in their respective places in the covalent bond. At any temperature of the absolute 0, the electrons have got some kinetic energy, and if the kinetic energy is sufficient as to break the covalent bond, these electrons escape out of the covalent bond and they are projected as free electrons. These electrons can move about freely in the vacant spaces of the silicon crystal. Now, you can understand that in order to ensure conductivity of this intrinsic silicon, you have to deliver sufficient amount of energy as to break the covalent bond and ensure that these electrons move about in the free space. So, this is further improvised by doping a silicon crystal with impurities. So, in the next class we will read about this intrinsic and extrinsic semiconductor.